Okay, guys, in this video, we are going to look at a binomial experiment and its properties. So to understand binomial experiment, I have a little app here that can simulate tossing of a coin. So imagine that I tossed a coin, I don't know, 5 times, 6 times, whatever. So sometimes the coin lands heads and sometimes it lands tails. So this experiment is what they call independent repetition of trials. So just imagine that each trial is a flip of a coin. There are only two possibilities. There's only heads or tails. There's no more. So that's why the experiment is called binomial. Also, we need to make sure that the number of trials is fixed. In other words, we know how many times we're going to be uh, flipping this coin. So in this case, for example, we flipped it 6 times. So we know that. Also, probability of success, which success would be depending on what we want. Whichever one of the two possible outcomes, we will set aside and say, okay, this is success. So for example, heads could be success, but if that's not what I'm interested in, maybe tails is success. It just depends on what is convenient for me. But the chance of success, in other words, the chance of getting heads will not change no matter which trial it is. So it's going to be exactly the same. So you can't just, switch a coin and change it to something that has a higher chance of getting heads midway, okay, of your tossing it. And also that the coins are independent. So what that means, the coin tosses. Like if I'm about to flip a coin right now, and I know, for example, that previously I got a lot of tails. Okay, so I'm thinking, so next time around, I'll have a bigger chance of getting heads, right? No, it's not right. It doesn't really matter what happened before. The next one is going to have the same chance of heads. So that means that the trials are independent. So these are the four properties that are listed here that I just talked about. And now what we want to do is look at these different scenarios and decide, does this work? Is this a binomial experiment? Because if it's not, you're not supposed to use it to compute probabilities. All right, so the first one says, I take a card from a well-shuffled deck until I get hearts. So just imagine that you keep taking hearts, they keep taking these cards. So I have another one here that is going to simulate drawing cards. And what I'm doing is like waiting for a heart, right? So I have to keep waiting for a heart. So once I see it, I stop, right? So just let's reset it. So for example, this time around, I didn't get a heart, didn't get a heart, didn't get a heart. No, 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 it's a diamond. Oh man. Okay, I'm really unlucky. So do I really know how many of them do I have to take until I see heart? No, I do not. In fact, now I got it. In fact, I don't know. It could be the first card is hard. It could be that I have to, as you can see, draw 14 cards until I see the one that's a heart. So in this case, I do not know how many. So this is not a binomial experiment because the number of trials is not fixed. Now here it says, draw 10 cards with replacement from a well-shuffled deck. For the first two cards, note whether it's a spade and then put it back in the deck. For the next 8 cards, note if it's a red card, okay, before replacing it. So every time it's like the same experiment. I take a card, I look at it, I see if it's a spade, put it back. So the trials are going to be independent. However, what's the difference here is that the first time around, I label success as whether it's a spade or not. And then chance of a spade is 1/4. But for the next ones, I am only looking at whether it's red or not red, and the chance of that is 1/2. So you are switching the success probability midway through your experiment. So that's not a binomial experiment because the success probability is not the same. For next one, it says, I draw a card from a deck. I note its suit. So what is it? Like, is it heart? Is it, club? Is it spade? Whatever. And then I put it back. And I repeat this process 4 times. Now, this is also not going to be binomial because from the word bi, that means that you only have two possible outcomes. And here you can have, diamond, heart, spade, club. So that's not going to work. So this is not a binomial experiment because it has more than two possible outcomes. In the next example, it says, which is really tricky, it says, we draw a card, note whether it's a club, replace it, and we repeat it 4 times. Is that really a binomial? So let's just think about that. Okay, so I'm taking it 4 times, right? So I know the number of trials is fixed. Every time I'm looking, is a club or not club? So there are 2 possible outcomes. The chance of a club is 1/4 the whole time. And trials are independent. In other words, the chance that I get a club the next time around will not depend on the previous because I'm replacing the card. I'm putting it back in the deck. I'm reshuffling it. So looking at all of that, I do not see any problem. So I think this is binomial. All right, let's look at this one. This one may be the trickiest one of all. Now, this one says, I draw 11 cards in succession. It does not say anything about putting the card back. And I'm just counting the number of diamonds. The problem with that situation is that if you take the first card and it was a diamond, that's going to change your chance of a diamond on the second time around because originally you had 13 diamonds, but now you're only going to have 12. So that means that there is going to be a different probability. It will be 12 divided by 51, right? Because only 12 diamonds are left and there are 51 cards left in the deck. Originally there was 52. So here, because we're not replacing the cards back, the probability of a diamond on the next trial is going to depend on what happens on the previous ones. So this is not independent. That's why it's not a binomial experiment.